morning everyone. Today we are going to see operating system unit 3 session 6. In the previous session we have seen the solution to the critical section problem. We have seen the approach strict alternation approach where this algorithm was synchronizing two processes. It was able to meet mutual exclusion condition and bounded waiting, but this algorithm was failing to meet the condition progress. Even if the processes were not interested, the processes were forced to enter into the critical section. So in today's session we are going to see another solution, that is Petersons solution. So this algorithm was implemented by the person Petersons, and we are synchronizing here two processes, and we are going to check here whether this algorithm meets all the three conditions of the critical section. Petersons solutions provide a good algorithmic description of solving the critical section problem. This solution is restricted to two processes that alternate execution between their critical section and remainder section. The two processes share two variables. So in this algorithm, both processes are going to share two variables. So the two variables which are used is turn and Boolean flag. In the previous algorithm we have used only the turn. Now in this algorithm we are also going to use the flag variable. The variable turn indicates whose turn it is to enter into the critical section. So why we use the turn variable in this algorithm? To find out that who is going to enter the critical section. And why we are going to use the flag in this algorithm, that is array of flag, is used to indicate if a process is ready to enter the critical section, and if the value of this flag is true, then it indicates that process P1 is ready to enter into the critical section. Now if this flag value is false, then we need to understand that the process is not ready to enter into the critical section. So this is the algorithm, Petersons algorithm for process P1, P0, and this is for process P1. So at the beginning the flag value is going to be false only, that is this is the flag value, and flag of 0, and this is flag of 1. So both are going to be false at the beginning. Flag of 0 is false and flag of 1 is also false. So now the process P0 wants to enter into the critical section. So it sets the flag value is equal to true. So now it is going to set the flag value is equal to true. So flag of 0 and 1. Flag of 0 it is going to make now true. And flag of 1 is going to remain false only. Now it is also going to make the turn value is equal to 1. So the turn value is equal to 1. Now it is going to check the condition here. So in the condition the turn value is equal to 1. The condition is true here. The condition is true. And the flag of 1 is equal to true. So I want to check here the flag of 1. You can see here flag of 1 is false. So flag of 1 is false. So the first condition turn is equal to 1 is true, and flag of 1 is equal to true. This condition is false. So one condition is true and one condition is false, means the condition is going to become false and it is going to enter into the critical section. So whenever the while condition loop is false, it comes out of the loop and enters into the critical section. Whenever this while condition is true, then the processes get stuck into the loop. Now as the condition is false, you can see here one is true and false. The condition is false. It is going to enter into the critical section. It is going to execute it, and then after finishing the execution it is going to set the flag of 0 to false only. Then again it is going to make the flag of 0 to false only. Now let us check for progress condition. Progress condition. So in a progress condition, the processes, those who are interested to enter into the critical section, only those processes are allowed to enter into the critical section. So flag value is set to true and false. So at the beginning, both flag of 0 and 1 is going to remain false only. So the process P0 wants to enter into the critical section. So it sets the flag value to true. So flag of 0 is true now here and flag of 1 is false here. And it also makes the turn value equal to 1. Now here the first condition in the loop is true and the second condition is false here. So if it is false, indicates that P1 is not interested to enter into critical section. So P0 enters into the critical section and it executes. And it comes out of the before coming out, it is going to change the flag of 0 equal to false. So flag of 0 it is going to make again false. Now again P0 wants to enter into the critical section. So again the P0 enters into the critical sections. So it sets again flag of 0 equal to true. It again sets flag of 0 equal to true. And here flag of 1 was false only. So then it is going to make turn equal to 1. So turn is 1 only here. So first condition is true. Second condition is false only because you can check here. The flag of 1 is false only. So again here one condition is true, one condition is false. So condition is false, enter into the critical section and execute. See, progress condition also we are meeting here. Now let us check for deadlock condition, whether the two processes will go in a hanging mode or no, whether they get stuck or no. If two processes wants to enter in critical section at the same time, then we are going to check whether it goes into the deadlock. So at the beginning the flag values are false only. So let's start with P1. So P1 wants to enter into the critical section. So it sets flag of 1 is equal to true. So it sets flag of 1 is equal to true. Flag of 0 and 1, and this it is going to make true value, and flag of 0 is going to be false only. Now it makes turn equal to 0. Now what happens here? In between the other process interrupts. The P0 interrupts in between here. And now the P0 takes the charge and now P0 is going to execute now. So when the P1 was executing, it has executed only first two lines and in between the P0 has interrupted and it has taken the charge. Now P0 is going to execute. Now P0 is going to make the value of flag of 0 equal to true. So it is going to make the value of flag of 0 which was false, it is going to make true here. And it is going to make turn is equal to 1. Now when process P0 enters into the loop, it checks for the condition turn is equal to 1 as condition is true. It is going to check flag of 1 is equal to true. As see here, flag of 1 is true only here. That means both the condition is true here. That means this while condition is going to return true value. So whenever the while condition is true, the process is going to stuck there. So indicates that there is already a process inside a critical section. So because of this, all the conditions are true, both the conditions are true, that particular process has got stuck into the while condition. Now let us check whether P1 can execute or no. P0 has stuck there. Now let us check whether P1 can execute or no. So now P1 enters into the loop. It checks here whether the value of turn is equal to 0. So the value of turn is 1 here because the turn value is changed by process P0 here. Okay, it was changed by the process P1. So the turn value is going to be here 1. And the flag of 0 is equal to true. What is the flag of 0? Flag of 0 is true only here. You can see here it is true only. So here in this case first condition is false and second condition is true here. So the condition, this while condition is going to return false only because one of the condition is false here. So now here P1 is not going to stuck here. The P1 is going to enter into the critical section and it is going to execute. And here P1 is going to stuck until when the P1 makes the flag of 1 is equal to false. So like this way we can also meet here the deadlock condition. That means both processes are not going to go in a hanging mode. So because of an interruption, both processes were going in a hanging mode. Even that can be solved here due to the turn and flag value. So in this algorithm, all conditions are achieved: mutual exclusion, progress, bounded waiting, and also the deadlock handling situation. Even this can be handled. And one more, bounded waiting means when one process is in critical section, other process got stuck in loop. Means other process is waiting in loop, so that until that process finishes the execution and makes or changes the flag value, that much time the process has to wait into that loop. Okay, until that other process changes the value of that flag or turn value, that much time the process has to wait into the loop. So we have seen this in the previous session, that when the process wants to enter in the critical section, they disable the interrupts so that other processes should not interrupt in between. And after finishing critical section, again they enable the interrupt so that the processes which are waiting outside can enter into the critical section. So this means when a process is executing in its critical section, it cannot be interrupted. But this solution cannot be used in multiprocessor environment. So in a multiprocessor, there are more than one processor which operates. So in such systems, in multiprocessor systems, several processes are executing concurrently on different processes. So here, in order to disable the interrupts, the instruction is to be sent to all the processes. So in order to disable the interrupts in multiprocessor environment, the instruction has to be sent specifically to all the processes that a specific process is going to enter into the critical section. So such instruction has to be sent to all processes. So to solve this problem and to achieve mutual exclusion in multiprocessor system, test and set instructions are used. So test and set instructions are used to solve this problem. So these are simple hardware instructions given to the processors that solve the critical section problem by mutual exclusion in an easy and efficient way in a multiprocessor environment. So this is the test and set instruction. So this function is going to return the boolean value that is either true or false. This is the function name and the argument is passed here. So the lock value is passed as here the argument, and this is the beginning code where the processes are going to enter into the critical section. So all processes share boolean variable lock and it is initialized to false. So at the beginning, all the lock variable is initialized to false. So whenever the value of lock is false, we need to understand that there are no processes inside the critical section. So whenever the lock value is true, we need to understand that there is some process inside the critical section. So at the beginning, the lock value is false. That means there is no process inside the critical section. So the process enters into the while loop to enter into the critical section. So there is an instruction test and set function is called here, and here the address is passed as argument here. So here instead of the value, the address is passed here of the lock variable, because we have used here ampersand or AND operator where the address of lock is passed. So here the pointer variable is used to fetch the value from that address. So why the address is passed here? Because so whenever you make changes in the value of that variable, it is also going to affect everywhere. It is going to affect in the function as well as in the main function. The value of that, so the value of this lock is going to affect everywhere, because you are changing the value in the address and not in the copy of the variable. That's why the pointer variables are used. Now here the value of lock is false. The value of lock is false is passed here, and that is stored in the variable RV. False is stored in the variable RV, and then in this lock variable true value is stored, and this RV is going to return the value false. So this test and set function is going to return the value false. So this function is going to return the value false. So whenever the condition is false, it is going to come out of the loop and it is going to enter into the critical section. So this while test condition is false now. By executing test and set instruction, it has returned the value false. Now the process are allowed to enter into the critical section, and after execution of critical section, the lock value is going to be made false here. It is going to again change the value of lock. It is going to make the value of lock false. So in a lock, false is stored. So from this table, we can understand here there are three variables: lock, lock value and R value. So this lock value is available in the entry section, and these both are available in the test and set function. So initially at the beginning, the lock value is false only, and whenever it is in the entry section also, the lock value is false only. And when it goes to the test and set function, there also we are initializing the value of lock false only, and the lock value is also false there. Here you can see in the function. See, at the beginning the lock value is false only, and again we are initializing the lock value false. While returning from test and set, the lock value is going to be true and R value is going to be false. You can check here. While returning, see, the R value is false and the lock value is true. See, lock value is true and R value is false. And then P1 enters into the critical section, and the value of lock is true now. Here you can see the value of lock is true. That means it will not allow the other process to enter in between, because already the process P1 is in the critical section. Now suppose if other process P2 tries to enter into the critical section, what happens? See, in the entry section, when the process tries to enter, then it finds that, see, when the process P2 tries to enter into the critical section, it finds out that the lock value is true now. That means it is locked and it does not allow to enter into the critical section. So that process gets stuck here. So unless the lock value becomes false, it will not allow that process to enter into the critical section. So lock value is true here, and then in test and set also the lock value is going to be true. See here, it is true again. So in this value is also going to be true. Now it is going to initialize true only here, and you can see here the lock value is only true here. So lock value is true here. Then while returning, both lock value and the R value is going to return true. So like this way, it does not allow the other process to enter into the critical section. This solution is suitable in a multiprocessor environment where there are more than one processes operating at a time. Concurrently they are working, and using a test and set instructions, the messages can be sent to the processes that the processes, when they want to enter into the critical section, after entering into the critical section, no other processes are allowed. It is locked. So addresses are passed here, so that when you change the value of lock, it is going to affect entirely to all the processes, to all the processors. So in today's session, we have seen the solution on critical section. Thank you.